So f of x equals x squared plus 2x minus 8. What we're going to want to do here, okay, is find, okay, same directions, except there's a problem here. You should notice right away what type of function f of x is. This is a quadratic, okay? We should now know that a quadratic will not pass the horizontal line test as is. If it's not going to pass it as is, that means if you need the inverse to be a function, you would need to restrict the domain. Now, when you have a u, the type of restriction that you need to do is you need to keep the entire range, but eliminate domain, okay, part of the domain, so that you pass the horizontal line test. So you either have to eliminate that part, or you have to eliminate the part to the right. So notice, the vertex is a super important part here, okay? I'm in standard form. I don't want to be in standard form. You must put this into vertex form, okay? You need to put this into vertex form for one of two things. Number one, because you need to be able to grab the vertex, and number two, because when you are algebraically getting the inverse, okay, you do not want multiple variables of the input, x, okay? So we need to put this into vertex form. So that's completing the square here, right? We need to write this. How do you go from standard form to vertex form? That's completing the square. So add 8 to both sides. That's going to give us f of x plus 8 equals x squared plus 2x. Now we have to add in that value so that the right-hand side would be a perfect square trinomial, and we have to make sure we add that to the left as well. So half of this squared, we can go right to completing the square because a is 1, right? So half of this squared would be 1. So we have to make sure we add 1. So this would be f of x plus 9 equals x plus 1 squared, right? Half of this. So now, whoops. So now we take away 9 from both sides and we get x plus 1 quantity squared minus 9. So now, okay, now we can start doing everything we have to do here. So number one, we have to graph each of them. So now we know, okay, if we just go as is, okay, and we don't do number 4 yet, f of x, the vertex here is -1, -9. So when I make a table of values, okay, I'm going to put -1, -9 in the middle of my table. And then if I plug in 1, okay, 1 plus 1 is 2, 2 squared is 4, 4 minus 9, that's going to be -5. So -3 is also going to output -5. If I plug 0 in, 1 squared, 1, 1 minus 9 is -8. Okay, so if I graph this, -3, -5, -2, -8, -1, -9, 0, -8, and 1, -5. There's my u. Now, will the inverse be a function? No, it will not. Will not be a function. -5, -3, -8, -2, -9, -1, -8, 0, -5, 1. Look, 2 different inputs are giving you different outputs. That means, okay, one input giving you 2 different outputs. You're failing the vertical line test, okay? -5, -3, -8, 1, 2, 3, 4, 5, 6, 7, 8, -2, -9, -1, -8, 0, and -5, 1. So look, you have that sideways u again. So how am I going to get it so that my inverse is a function? I'm going to take away the part of the domain of f of x, therefore part of the inverse gets taken away. So that was number 1. Now number 2, f of x, okay, domain range, inverse. Can't write the inverse notation because it's not actually an inverse yet. Domain and range. So the domain is all real numbers, and the range for f of x would be y is greater than or equal to -9. So right now, the domain of the inverse is whatever that is. So x is greater than or equal to -9. And the range would be all real numbers. Okay? So now we're going to get the inverse equation. Okay, so I'm going to hold on to, we wrote this was x plus 1 squared minus 9, right? Okay. So now part 3 says get the inverse equation algebraically. Okay, so we're going to swap y equals x plus 1 squared minus 9. Now let's say you did not use vertex form, okay? The other way was y equals x squared plus 2x minus 8. And now we have to swap x and y. So I'm going to show you something, okay? X equals y plus 1 squared minus 9, okay? And then if you kept it in standard form, you would have x equals y squared plus 2y minus 8. And remember, what we have to do is get y by itself. Notice, I can get y by itself here by adding 9, taking the square root, and subtracting 1. I will not be able to get y by itself if I have a y squared and a y term. If I have the quadratic term and the linear term roaming around, I can't get y by itself. I have to complete the square in order to get y by itself. So you might as well do it from the beginning when you have to graph anyway and identify what the vertex is. So you can't, okay, if you go like this, you still have to complete the square, okay? So sure, it's fine to write this, but then notice the only way to get y by itself, if it's a quadratic, y has to end up as the square of a binomial. So you need to make sure that you are in this form when you start finding the inverse. So now we add 9 to both sides. Take the square root. This gives you plus or minus the square root of x plus 9 equals y plus 1. Now take away 1 from both sides. And this would be the inverse equation, but right now, this is not a function. And this is not a function because if I plug something in for x that's allowed to be plugged in, I'm going to get 2 different outputs, except if x is -9, okay? If I plug in 0, okay, 0 plus 9, the square root of 9 is 3. That means I would have to do positive 3 minus 1, which is 2, and then negative 3 minus 1. So 0 gives me 2 different outputs here. That's a problem. So what you do is, number 4, okay, what we do is we restrict the domain of the original. So instead of f of x having a domain of all real numbers, okay, let's choose, instead of keeping the right-hand side, why don't we get rid of the right-hand side this time? So our domain would be x is less than or equal to -1. And the range did not change at all. It's still y is greater than or equal to -9. Now that we got rid of this part of the u, okay, that means for the inverse, okay, the domain is staying the same. X is greater than or equal to -9, but you're not going to produce all real numbers. Now, you're going to produce outputs that are only less than or equal to -1, which means this entire top part of the inverse is gone. So, is the inverse now a function? Yes, it is. And so, in terms of this equation, you don't produce values now, outputs that are greater than -1. This positive part of this radical is what's producing that. So you only keep the minus part because your outputs should only be less than -1. Okay, so when you have a function and its inverse would not be a function, and you need the inverse to be a function, you must restrict the domain of the original. Okay? Then what happens is the range of the inverse gets restricted, and just be careful, make sure you make your new equation, you rewrite it so that it only shows the correct range that you would get. Okay, so that is it for inverses.